Variable flow meter. It operates at a constant delta pressure and the error change with the flow rate. As the higher flow rate, the fluid rises to increase the area between the tube and the fluid and maintain a constant delta pressure. Three main forces act on the fluid. First is the buoyancy, A, dependent on the density of the medium and volume of fluid. Second is the weight, G, dependent on the mass of fluid. Fluid can be manufactured using stainless steel, aluminium, titanium, or hard rubber. The flow force S, the flow force changes transitionally with change in the flow until a new state of equilibrium has been achieved. Variable area meter are directly used for metering gas, but different type of available for variety of different fluids. A buoyancy correction term is required for liquids and dense fluid. Variable area flow meter are simple yet versatile flow measurement instrument that can be used at any liquid, gas, or steam. They work on the variable area principle, which involve a flowing fluid changing the position of a fluid, piston, or vein to let the fluid to travel through a greater area. A direct visible indicator of the flow rate is provided by the position of the fluid, piston, or vein.
Rotameters. The rotameter is an industrial flow meter used to measure the flow rate of liquids and gases. Its operation is based on the variable area principle, which is fluid flow raises a fluid in a tapered tube, increasing the area of passage of the fluid. The greater the flow, the higher the fluid is raised. The height of the fluid is directly proportional to the flow rate. With liquids, the fluid is raised by a combination of the buoyancy of the liquid and the velocity head of the fluid. With gases, buoyancy is negligible and the fluid responds to the velocity head alone. The fluid moves up or down in the tube in proportion to the fluid flow rate and the annular area between the tube and the tube wall. The equation for the volumetric flow rate is Q equal to Ka square root GH, where Q is volumetric flow rate per minute, K is a constant, A is the annular area between the fluid and the tube wall, where G is gravitational force and H is the pressure drop across the fluid.
Okay, for advantages and disadvantages, the rotameter is very popular because it has a linear scale, a relatively low measurement range, and low pressure drop. As we can see from the picture given, the flow of a liquid or gas flow from butter and go to outside, and it is very simple to install and maintain, and then it can be manufactured in a variety of construction materials and designed to cover a wide range of the pressures and temperatures. Alright, the rotameter can easily be sized or convert from one kind of the service to another. In general, it was used to versatility of construction and application. Because of its very functional advantages, the rotameter is an exceptional practical flow measurement device variable area flow meter are commonly used to provide cost-effective local indication of small liquid or gas flow. And then for the disadvantages, its low accuracy or uncertainty on volumetric flow rate is 2% of readings, and then generally small turndown, tendency of float to stick at low flows, and then disadvantage of variable area flow meters is requirement for buoyancy correction in liquids, and then application caution for variable area flow meters. And last but not least, for disadvantages of variable area flow meters, do not apply variable area flow meters to liquid that are opaque, dirty, or prone to coat the metering tube or float, because this may render the flow meter inoperable. That's all from us.